Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 2, Section 4, Equations with Variables on Both Sides. By the end of this video, you will have reviewed methods for solving equations with variables on both sides, and have also reviewed special case scenarios by addressing identities and equations with no solutions. To round off the review, you will look at a real-world problem. If you'd like me to cover any of the topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you very much. Okay, before we get going on this review, we'll check with the definition here. It says an identity. An equation that is true for every value of the variable is an identity. So that'd be like saying 2x equals 2x. So that equation is always true. It's called an identity. Okay, objective 1, solving equations with variables on both sides. To solve an equation that has variables on both sides, use the addition or subtraction properties of equality to get the variables alone on one side and the constants on the other side, okay? On the other side of the equal sign. And then, if needed, use the multiplication and division properties of equality to undo any multiplication or division related to the variable's coefficients. Okay, example 1, variables on both sides. Find the value of x in the diagram to the right. Oh yeah. So this is saying here that these lines, cross lines, form equal opposite, they're opposite angles, or they're verticals, what they call them. Vertical angles are congruent. So we're going to rewrite this. We're going to write the equations that's formed by this diagram. And when you do that, you get 6x plus 3, which is this part here on this side, 6x plus 3, equals, because we know these vertical angles here are congruent, means they're equal. So equals 8x minus 21, okay, in degrees. So there's our equation. 6x plus 3 equals 8x minus 21. So now we can solve it. So how to solve it? We're going to solve it, we're going to subtract the 6x from both sides. So we have to get, because there's the variables are on both sides, right? So we have to move one, pick one and move it. So what we're going to do is we have 6x plus 3 on one side. So in order to move that, we're going to subtract a 6x plus 3 from both sides. And when we do that, the 6x's will disappear. That's this point of the 6x here, and this one will disappear. And then they'll have a 6x minus 6x on this side. And those two will combine, and you'll get 2x. 8x minus 6x is 2x. And then you'll have the 21 still remaining and the 3. So 3 will be equal to 2x. That's the 8 minus 6x minus 21. So now we have to get the 21 on the opposite side because we're going to get the variable alone. So now we're going to take the 21 and we're going to move it to the left-hand side. And to move a negative 21 to the left-hand side, we're going to add 21 to both sides using the addition property of equality. So now we're going to have, we've moved it, here's the 21 plus 21 on both sides. And when we add the 3 and 21 together, we get 24. And these over here, these cancel, and we have 2x. So it's 24 is equal to 2x. In order to get the coefficient to 1 with the x, we're going to divide using the division property of equality, divide by 2 on both sides. So in doing so, we're going to have 24 divided by 2 on the left and 2x divided by 2 on the right. The 2's will cancel. These 2's right here will cancel. And the 24 will be divided by 2 will give us a 12. So we're going to have x equals 12. So the value of x is 12 for these vertical angles over here. Okay, solve each equation. Check your understanding. Example 1. If you've been with me before, you know what this means. If you haven't, what I'm asking on these check your understanding slides, I'd like you to stop the slide, the video, stop the YouTube, and try the problems yourself. Take as long as you want to work them. And when you get them all solved, come on back and we'll work them together. Okay? So I'm going to wait for you. Okay, I'm glad you've returned and we're working together on this. So let's go to problem A. What's the first thing we do? We rewrite the equation. I always write the equation. Minus 6d equals d plus 4. So what do we have to do? Well, we have d on both sides of the equation, and we have, well, basically that's all we're going to do is we're going to move the d. Okay, so in order to move the d, we have to subtract d from both sides of the equation. And when we do that, we're going to have minus 6d minus d equals d plus 4 minus d. That's where we subtract d from both sides right here. Okay, so now that we've done that, we've got um, the d's are together, and then there's only one constant, and it's the 4. So now we're going to combine these d's, and we're going to get negative 60 minus d is negative 7d equals what? It equals, these d's cancel, so it equals 4. So now what does d equal? We're going to divide both sides by negative 7 to get the d by itself with a coefficient of 1. To get a coefficient of 1, we're going to take and divide both sides by negative 7. So we're going to have divide this side negative 7 and this side by negative 7. When we do that, we'll have d is equal to negative 4/7. Okay? Okie doke. Let's do problem B. We're going to start off by writing it again. 2 times the quantity c minus 6 is equal to 9c plus 2. First of all, we're going to multiply using the distributive property, we're going to multiply 2 times each of the terms inside the parentheses to get rid of the parentheses. So we're going to end up with 2c minus 12 is equal to 9c plus 2. So let's move doesn't matter which way we go. Let's move the 12 to the right and the 9c to the left. So in doing so, we're going to have 2c um, minus 9c minus 12 is equal to 9c plus 2 minus 9c. So these the 2 and the 9c will add. We're going to get minus 7c minus 12 is equal to, the 9c's cancel, is equal to 2. Now we want to get the negative 12 to the right-hand side. 7c plus 12 minus 12 is equal to 2 plus 12. And that means we're going to have negative 7c. These 12s cancel, equal 2 plus 12 is 14. Okay, and I'm going to have to move over here because I ran out of room. So we're going to have, to get rid of the 7, we have to divide both sides by negative 7. And when we do that, we're going to get negative 7c divided by 7, okay, is equal to 14, right, divided by negative 7. I guess I could have put the negative down here instead of up here. I'll do that. Just so it's clear, I'll erase that one. So the negative 7's on the bottom so that you keep it together, negative 7. So now the 7's cancel and you get c is equal to negative 2. Okay, m minus 5 is equal to 3m. So we're going to get the m's together. We'll leave the 5 on the left-hand side. So we're going to subtract m from both sides. Minus m plus m minus 5 is equal to 3m minus m. And when we do that, we're going to get the m's canceling on this side. We're going to get negative 5 is equal to 2m. Okay, and when we divide both sides by 2, because we have to get the m by itself with a coefficient of 1, we're going to divide each side by 2, divide this side by 2, divide this side by 2, and we're going to get, I'm going to move the m over when I write it, m equal to minus 5 halves. Now the last equation, 7k minus 4 equals 5k plus 16. I'm going to move the negative 4 over. I'm going to say 7k minus 4 plus 4 is equal to 5k plus 16 plus 4. Okay, that's going to give us 20. So we're going to have, so we have the 7k. We've gotten rid of this. We haven't moved the 5k. So we have 7k is equal to 5k plus 20. And we're going to move this, get rid of the 7k and make by, well, we're not getting rid of it, but we're going to move over the 5k and we'll clear up the constant by itself on the right, and we'll have the variables on the left. So we're going to subtract 5k from both sides. 7k minus 5k equals 5k plus 20 minus 5k. So now we're going to have 2k on the left, and that's equal to, the 5k's cancel, is equal to 20. K is equal to 10 because we divide both sides by 10, or times 1/10. Each side times a tenth, and you get an answer of k equals 10. Okay. So example 2, real world problem. You can buy used inline skates from your friend for $40, or you can rent some. Either way, you must pay a rental safety equipment fee. How many hours must you skate before the cost of renting and buying skates will be the same as renting the skates and the equipment, the safety equipment? And this says, see the rental sign at the right. Well, what it says over here, it says rentals, skate rentals, inline skates and safety equipment, $3 an hour. Safety equipment alone is $1.50 an hour. So how are we going to solve that? So let's relate the statement to, let's start putting it into a form of an equation so we can think about it. So we have the cost of the friend's skates plus the cost of the safety equipment, and that equals the skates plus the equipment. Okay, so now what we want to know is when that's, so we got the safety equipment alone and then the skates plus the safety equipment on the other side. When are they going to be equal? And when they're equal, that's basically, we could go either way, but when it's all of a sudden, it's going to end up being cheaper to have bought your skates, and that's what we're looking for. So we're going to let h equal the number of hours that you must skate. Okay, and now we're going to write the equation. The cost of the friend skates was $40 plus the $1.50 per hour for the rental equipment, the safety equipment. And then that's going to be, and when is that going to be equal to the $3.50 an hour to rent and the equipment and the skates? So let's rewrite that in the form of the equation, which is 40 plus 1.5h equals 3.5h. And when you do that, you have 40 plus 1.5h minus 1.5h, because we're going to move the 1.5 to the other side. And that equals 3.5h minus 1.5h. Right here. 3.5h minus 1.5. These cancel. So we have 40 equals 2h. 3.5 minus 1.5 is 2. 2h. 40 equals 2h. Well, how much is 1h? Well, we have to divide both sides of the equation by 2. And when we do that, we're going to end up with h. 2 over 2 is 1. H equals 40 divided by 2, 20. So that you must skate 20 hours for the cost to be the same. And then for anything after that, it'd be cheaper to have what? Bought the skates. Okay? Okay, a hairdresser, here's now your problem. You're going to try it on your own here. A hairdresser is considering ordering a certain shampoo. Company A charges $4 per 8-ounce bottle plus $10 handling fee or per order. And company B charges $3 per 8-ounce bottle plus a $25 per order fee. How many bottles must you buy? Must the hairdresser buy to justify using company B, or it's going to have, and the justification is the fact that you have a higher fee. Okay, so how would you solve that problem? Well, this is a check your understanding. So I'll let you go off and try it on your own, and when you come back, we'll give it a shot. Okay. Okay, so we have two sides of an equation, and the two sides say what? The two sides say on one hand you have four bottles, $4. I'll just say it. You have $4 per bottle plus 10, right? And I'm going to say the bottles are, we'll call them B for bottles, okay? So it's going to be on the one side you're going to have 4B plus $10. And when will they equal each other? When they equal, from then on, it's cheaper to buy to have the higher fee. So we're going to have plus or equals rather, excuse me, 3B, $3 a bottle plus 25. And now we have to solve this for B. B is how many bottles will I have to order for the one with the higher delivery fee to be worthwhile? So we're going to take and let's move the b's together. So we're going to be subtracting 3b from both sides. So I'm going to have 4b plus 10, that's the delivery fee, minus 3b is equal to 3b minus 3b plus 25. Okay, so now I have 4b. Well, I'm just going to write out the answer. I'm not going to move them around again. Okay. So 4b minus 3b is 1b plus $10 is equal to, the 3b's canceled, is equal to 25. Oops. I'm getting a little wild with my hand, with my writing here. 25. So now I have to get the 10 away from the b, so the b's by itself. Wow. If I do that, I'm going to have b plus 10, plus 10 minus 10 is equal to 25 minus 10. Okay, so now the 10s cancel on the left-hand side. I have b for bottles equals 25 minus 10, 15. When you or the hairdresser purchases 15 bottles at a time, it's cheaper to go with company B. Otherwise, it's cheaper to go with company A. Okay. Objective 2. Special cases, identities, and equations with no solution. An equation has no solution if no value of the variable makes the equation true. The equation 2x plus 2x equals 2x plus 1 has no solution. There's no number you can put in for x that will give you each term to be equal. Okay, an equation that is true for every value of the variable is an identity. The equation 2x equals 2x is certainly an identity. Okay, example 3, identities and equations with no solutions. So what we're going to find out here is we're probably going to see one of each. And in doing so, we want to look at it and see which one is it that is the identity and which one has no solution. So let's start with problem A. So we have, I'm going to rewrite it, as I always do. 10 minus 8a is equal to 2 times the quantity, 5 minus 4a. First thing we're going to do is we're going to separate the two terms within the distributive property here. We're going to multiply through by 2, and we're going to get 10 minus 8a is equal to 10. 2 times 5 is 10 minus 8a. Oh, well, guess what? If we take and bring the 8a onto one side, if they're equal, if you try to get the 8a's at the same side, you're going to end up with 0. Okay, so this is no matter what value you put in for 8. Let's say you put in a 2. So it's 10 minus 18, or 10 minus 16 is equal to 10 minus 16. It's obviously an identity. Let's try the next one. 6m minus 5 is equal to 7m plus 7 minus m. Okay, so let's do this. So let's combine the m terms. So we're going to have 6m minus 5 is equal to 7m minus 1m is 6m plus 7. Can these two ever be equal? You can never say that, because once you go to move the 6m to the other side, boom, 0. They cancel each other out. This can never be, in this case, this can never be true, because you have 6m minus 5 is equal to 6m plus 7. Can't be true. This is no solution. Okay, good deal. Okay, example 3. Check your understanding. Your turn. Determine whether each equation is an identity or has no solution. Same thing we just did in the previous slide. So why don't you go ahead and give it a try. I'll wait for you. Okay, I'm assuming you've done it and you're back with me. So, and I trust you've taken the time to try this yourself, just so you can feel it. Okay, so let's write the equation. 9 plus 5n equals 5n minus 1. Well, you can see right away that you cannot combine the 5n's together, can you? If you do, they're going to go to 0. And you can never say that 5n plus 9 is equal to 5n minus 1. It'll never be true. So this is no solution. And how about this one? 9 plus 5x is equal to 7x plus 9 minus 2x. Well, we're going to combine these. Here we'll combine the two x terms on the right. So we're going to get 9 plus 5x. That's what they ask us to do. 7x minus 2x is 5x plus 9. Oh, so now I have 9 plus 5x. Is that equal to 5x plus 9 or 9 plus 5x? And the answer is yes. Okay, so that is an identity. No matter what value you put in for x, they'll always be the same.